to be completely thorough, so I'll just cross off that 2. So now we're going to start with the 1, and we're going to multiply. We'll get rid of that little arrow there. 1 times 3 is 3. Where do I put the 3, though? Is it going to go here? Where is it? It goes under the 4? We go over a column automatically? Why? What are you going to say if a kiddo asks? Because that's the same thing over here, right? If I was to do, let me go back over here and do the normal way. 2 times 9, 18. And 2 times 4 is 8. Add 1, 9. And then when you started with the 3 next, you're done with the 2. You would go 3 times 9, 27. You go 20, and the 7 would go there, wouldn't it? Why? What are you going to tell a young person who asks you? You're going to say, if the kid says, why? Why should we do that? You're going to say, kid, don't bug me. Just do what I say. No more questions. What's the reason?
We're multiplying the next value, place value.
Right. Yeah, and what is that next place value? What is this or this in our system? The 3 is really not a 3 because of its place. Exactly. Jesus, right? Jesus. Yeah, because the 3 is sitting one place over. It's really 30. It's not really 3 because of the place in which it sits. It's really 30. And if you multiply 30 times 9, that's 270, not just 27. So when we write 2, 7, that's why we have an O back here. I would suggest you do have them fill in an O. I think it's a good practice. Not just for placeholding, but for meaning. That's why that means that, huh? Were you clear on that before? That's why we skip a place over, because now we're multiplying in the tens place. This is not 3, it's 30. So this is going to be 270, or wherever we write the 2, So it's the same thing over here in the base 5 system or any system. When you move one column over here, you got to move one column over there. You don't have to put a 0. I mean, you can just leave a blank, but you got to be one column over, don't you? Because you're multiplying by numbers of more place significance. So, all right. So 1 times 3 is 3, and then 1 times 4 is 4. And now what do? Now we draw a line and add them up. 5, 7, 1. We got it. Is that good? That's no good.
What place value would you call it, though, to a child? Would it be the tens or would it be the 25 place?
Yeah, right. It's, I don't care. Nobody's going to really ask you. But you're right. I mean, it's not in the base 5 system, it's the 1s, 5s, 25s, isn't it? Instead of, yeah, you're right. So I just say the next place because I don't want to confuse you with too much language. But yeah, you're right. Hey, is what I just did there adding okay? No, even here I'm in the base. It's easy to lose track, huh? Remember, we're still in the base 5 system. So when you add these up, you've got to add them up base 5, right? So 0 and 1 is 1. 4 and 3 is 7. What do I do with 7? In base 5. Carry a 1. That represents 5. Bring down the 2 left over. That's the 7. And then 4, 1, and 1 is 6. But what do I do with 6? Carry a 1, bring down 1, and bring down that last 1. 1, 1, 2, 1. Base 5. How are we doing? You good with all that? In base 5? All right, shall we try one? So I'm just going to make one up. You got the homework ones. Let's see, let's go 24, 33, and we'll do base 5 again before we branch into other bases. So try that one so you can multiply those in base 5. Okay. So 3 times 4 is 12. All right, 3 times 4 is 12. We'll write them over here to the side. 3 times 4 is 12. What do I do with 12, though? carry how many 5s away? Carry 2 5s, that's 10, and 2 left over. That's how many, that's the 1's place, the 5's place. It's 2, 2, base 5. That's 12, isn't it? 2 5s is 10 and 2 more. So I got to go 2, 2. Everybody good so far in that first step? Everybody see what happened there? So 3 times 4 is 12, which is 2 5s, 10, and 2 more left over, isn't it? Carry away 2 5s. Okay, do the next one. So 2 times 3 is 6. Add 2 is 8. How do I do 8? Carry 5. 1 5 away is 5, and 3 more for the 8. Good with the first one? So add a 0, because we're done with that one, and we're on to the next place value, aren't we? That's why we add a 0. Because these things we're multiplying by is not really a 3, it's a 3 in the next place value. That's why we do it. There's reasons for all these things we do in math. All right, try the next one. Hey, we're multiplying by the same number. It's going to be the same answer. Just moved over a column, isn't it? Right, it's going to be 1, 3, 2 again. So I'll go through it though. 3 times 4 is 12, which is 2 5s, bring down 2. And 3 times 2 is 6, add 2 is 8. 3 times 2 is 6, add 2 is 8, which is 5, and 3 more. Sure enough, same number, multiplying by the same thing. Add them up now in the base 5 system. 2 and 0 is 2. 3 and 2 is 5. So 3 and 2 is 5, but I can't write 5. Instead, I carry away 5, bring down 0. And then 3, 1, and 1 is 5, but I can't write 5. So I carry away 1, bring down 0. And 1 and 1 is 2. 2002. Base 5. It's getting easier. All right, let's do another multiply. We got to do divide eventually here. So let me try changing the bases. What else do they have? Here, let me see. They do base 3, 9. All right, and then multiplying, dividing. A couple dividing at the end. And, right. All right. Let's try like, let's try a base. How about, how many, do they have some 3-digit or 2-digit? 3-digit numbers, base 4, that looks good. Okay, how about 2, 3, 1, 3, 2, 2, all base 4. So we'll go for 3 digits on 3 digits now. So you're in the base 4 system. Two and 1 is 2 times 1 is 2. 2 times 3 is 6, which is carry away 4, bring down 2. 2 times 2 is 4, add 1 is 5, which is carry away 4, bring 1 down. How are we doing on the first level? 1, 1, 2, 2. Keep going. right, I'm going to jump in. If you're doing okay, start with a 2. Now I'm in the middle, so I'm going to add a 0. So 2 times 1 is 2. 2 times 3 is 6, which is carry away 4, bring down 2. 2 times 2 is 4, add 1 is 5, which is carry away 4, bring 1 down. Of course it's the same. 1, 1, 2, 2 again. We good? Now, of course, we add 2 zeros, don't we? Because now we're multiplying by the 3, which is 2 place values over. So if this was base 10, we'd say we're multiplying by 300 now, not just 3. So, of course, we're going to have 2 zeros in the end, in base 10. That's what you would show kids. I hope the beautiful, consistent logicalness of math. Not random decisions, but pure logic followed out. So 3 times 1 is 3. 3 times 3 is 9. What do we do with 9? What is 9? How many 4s do we carry away? 2 4s, 1 extra in base 4, huh? Right? Carry away 2 4s, that's 8, 1 extra. So 2, bring down the 1, and then 3 times 2 is 6, add 2 is 8. 8, what is 8? Carry away how many 4s? 2 4s, no extra. 2, no extra, like that. I'm going to add them up in base 4, still in base 4. You good to there? Questions I can answer to there? Are we doing okay? All right, I hope you're doing these just so you'll know what you need to ask and I can help you. Rather than just copying them down. Try to do them ahead of time. I hope that's working for you. All right, so 2 0 0 is 2. 2 2 0. That's 4, which means we do what? Carry away a 4, carry away a 1, none left over. Next. 1, 2, 3, 4, 5, 6, 7. 7. So what are we going to do? Carry away a 4, 3 left over, right? 3 left over, carry away a 4. Next column. 1, 2, 3, 4. So that's carry away a 4, none left over. 1, 1, 0 is just 2. The other 2 just comes down. And we got it. 2, 2, 0, 3, 0, 2. It ends up being a long number, doesn't it? Base 4. It's like 220,000, but it's not really 1,000. It's base 4. How are we doing? How many got that? Did you get all the way through that correctly? About half of you. That's good. Questions I can answer. How did this 2 here?
Yeah.
I think that was, right here I did 3 times 3 is 9. Yeah, and then the 9 is carry away 2 4s. From a total amount of 9, you can take out 4 again. 2 groups of 4, leaving 1 left over. Yeah, 2 whole groups of 4. Carry away, which is 8, leaving 1 left over, yeah. Is that good? You're dealing with base 10. So you might have to write some scribbles on the side. Convert things. Let me jump in with you. 5 times 2 is 10. So 10 is carry away 6, 4 left over. Not a big deal there. 5 times 5 is 25. Add 1 is 26. That's what I'm going to do on the side. I'm going to do him on the side. So we're looking at 26 right now, right? Now, I've got to carry away however many 6s I can. How many times, you just calculate it for everything we're doing, if you're a little rusty on some of those times tables, how many times does 6 go into 26? It'll go in 4 times. 4 times 6 is 24. Yeah, just divide in your calculator if you're rusty on some of those times tables. Goes in there 4 times. 4 times 6 is 24. So it'll go in, so you can carry away 4 6s. 4 groups of 6. Does that make sense? With 2 left over. It's 4-2 base 6, isn't it? Everybody good with that? So that would be 4-2. Try the next one if you haven't already. And you can use calculators on the test. They should rusty on some of those little details. I don't want you to get caught in little silly stuff. So next we go. 4 times 5 is 20. Add the 4. 24. So now I got to carry away however many 6s I can carry away. So how many 6s can you carry out of 24? 4 of them again, right? Exactly 4 with none left over. It's 4-0 base 6, isn't it? 4-0. We good so far? So we're done with that one. We're ready to do the 3. All right, so try the next one. So add a 0. Okay, so 3 times 2 is 6. So 6, that's just carry away a 6, none left over, huh? So carry away a 6 here, none left over. I already had the first 0 just because of the place value movement. And now I got a 0 because 1-0 was the answer for 3 times 2 being 6. Carry away 6, none left over, huh? All right, next one. 3 times 5 is 15. Add the 1 that's up here is 16. So with 16, you got to carry away as many 6s as you can. How many 6s can we pull out of 16? Yeah, if you're not sure, you can show it. You can subtract 6 twice, leaving 4 left over. So it's 2, 4, base 6, isn't it? If you want to do the subtraction thing, you could do that. That's the same. That's what dividing is. I don't know if you ever thought about that. Dividing is repeated subtraction. It's how many times you can take 6 out. It's how many times 6 goes in. So 2 6s go in there for 12 with 4 remaining. All right, so that means carry 2, bring down 4. Next one, 3 times 4 is 12. Add 2 is 14. How many 6s can we take out of that? 2 leaves 2 left over, right? Out of 14, carry away 6 and 6, that leaves 2, right? Carry away 12, that leaves 2. 2 6s left over with 2. So that's going to be 2, 2. On that, yeah. 24. This 24 right here, it came from the 16 right here. 3 times 5 made 15. Add 1 made 16. And 16, to get 16, I realized that's 2 6s, which is 12, and 4 more. That's what the 16 is. Yeah. Is everybody good with that? I'm sure the other people have the same question she does. Right? So 16 again, it's how many times you can take 6 out of it, right? Carry away 6. Twice, that subtracts 12, leaves 4. So that's 2 times I took 6 away, 4 left over. That's what the numbers mean in their various bases, don't they? How many groups of 6 you can take away. 2 groups of 6, right? Here's 1, 2 groups of 6, 4 remaining. That's what carrying and borrowing is all about. Bringing the base amount or carrying the base amount, isn't it? More clarity on carrying and borrowing than you ever had before, I hope. All right, so let's add them up. And we're still in base 6. So 4 and 0 is 4. 2 and 0 is 2. 4, this isn't too bad at all. 4 and 0 is 4. Nothing strange yet. 4 and 2, 6. So what do? Carry away a 6. None left over. 1 and 2 is 3. There it is. 30424. Base 6. How are we doing? That is good. You ready for dividing? The last leg of the journey. We've done everything in the foreign bases. Now divide. All right. So let's see. Let me try to imitate the homework here. So the homework. All right. 11022. Let me make that a little nicer. 11022 divided by 132 base 4. All right, so we want to divide in the base 4 system. There's all kinds of ways you could do this. I'm trying to think what might be the easiest way for you. I don't know. Okay, let's try it both ways. Let me just try doing a long division at first. How about that? Oh, that might be hard. Okay, let's try it. Honestly, I can't remember. It's been a long time since I've long divided in another base, and I don't remember which way is easiest to do. So I'll try it this way, just normal, standard long division. If this ends up being a little tricky, then I'll just do it by subtracting. That might be better. I don't know. We'll see. All right, so let's give it a try. So remember long division by hand? Has it been a while since you've long divided by hand? Right? So how do we do that? So what are we going to do when you long divide by hand? Well, first off, you don't think about the whole number at once, right? It's too much to worry about. You just think about what you can go into. Like, just think about normal. Like, if you were doing, 231 into 4, 7, 8, 6, 9, like that. You wouldn't worry about everything at once. You would just say 231 goes into 478, huh? You would just start there. And how many times does 231 go into 478? I'm talking about just normal numbers now, regular base 10. 2 times. You put a 2 there, right? You put a 2, and then you just multiply that 2. Boom, boom, boom. Then get 4, 6, 2. You'd subtract 16. Then you start bringing stuff down. You keep on going, right? Remember how that flow works? So let's keep that thought in mind. Let's come back over here to base 4 and say, okay, so I'm not worried about this entire number at once. That's too much. Just think about, okay, 132, does it go into 110? No, it doesn't go into 110. It's bigger than 110. That'd be kind of like if over here I had 408. Let me do a retake. I'm going to keep going back and forth to help you remember. I think it'd be easier, go back to what you're used to. So if I was doing normal base 10 over here, and I was looking going, okay, I changed the problem a little bit. 231 doesn't go into 408. Right? Oh, well, actually it does. It's not a good one. It doesn't go into 408. It does. 208, how about that? Doesn't go into 208. 231 doesn't go into 208. So what would you do? You'd go a little further. You'd include the 6, huh? You'd say, okay, I guess we got to go into 2086, and I don't know how many times that is, 7, 8, 9, whatever. You try to figure that out. Well, same thing over here. 132 doesn't go into 110, so you got to go into something big enough to go into. There it is. There's the first number big enough to get. It's bigger than 132, right? So you got to get just enough digits. Don't want any more, but just enough that are that's bigger than your number. So now, what am I going to put here? How many times does 132 go into 1,102? I don't know, 7 times, 8 times?
8 times.
What's that?
8.
Maybe 8. Let's remember something. What base are we in? What are we never going to see? 4 or bigger. It's either going to be a 0, a 1, it's not a 0, is it? It's 0, 1, 2, or 3. And it's not 0 or 1, it's got to be 2 or 3. You tracking with me? Did you understand all that logic? We're in base 4. We're never going to see a 4 or bigger anywhere here. So we only are dealing with the digits 0 through 3 for what I'm going to put up here. No way on a 7. If I put a 0, that'd be silly. 0 times anything is 0. That ain't it. And if I put a 1, that would also be probably not enough. That's just 1 times it. It's just 132. That's not enough, probably. So let's try 2 and let's try 3. I don't even know right now which one it is because I don't really think naturally in base 4 at all. So I'm just going to go over on the side and give it a try. So I'm going to take 132 and multiply by 2 in the base 4 system and see what I get. Because that's what you do, right? Anything you write up here is going to multiply that number on the side, huh? So let's try it out. 2 times 2 is 4, which is carry away 4, no more. 2 times 3 is 6, add 1 is 7, carry away 4, 3 left over. 2 times 1 is 2, add 1 is 3. It's 330. Yeah, 330, that works. It seems a little bit small. Maybe we should go to 3. I don't know. I'm going to try 3. Notice how it's a lot of guessing, and you've got to be a really good multiplier to do dividing, because it's basically dividing backwards. Dividing is multiplying backwards, huh? We got to keep finding what will multiply in order to divide, don't we? So let's go over here and go, okay, that came out 330. That seems like a lot smaller than 1102. Maybe we should try 3. That's the biggest number we can do. So maybe it's that one. I don't know. Let's try it. Let's try 3. And if that goes in, right, you want the biggest thing that'll go in, right? So let's try 3. 3 times 2 is 6, which is carry away 4, 2 more. Hey, hold on for 1 second. What if I was not very good at multiplying? What kind of chance am I going to have at long dividing? I'm dead. Math-wise. I mean, right? If you can't multiply, you're never going to be able to do it. What's my point in all that? Social promotion kills people in math. What do I mean, right? You know, where the child just like doesn't learn how to multiply in whatever, 2nd grade or wherever that is now. I was moving everything up. I don't know anymore. It used to be 4th grade when I was a kid, but now it's like in 2nd grade, I think. Anyway, if the child does not learn to multiply, and we just socially promote them and just say, yeah, they never learned to multiply, but they didn't hurt anybody during the year, so we're just going to move them along to the next grade where they're going to learn to long divide. Are they going to learn to long divide if they don't know how to multiply? No, while you're teaching long dividing and they're studying long dividing and they don't know how to multiply, they are completely gonzo. They are gonzo with no way of return. There's no way to learn to divide if you don't know how to multiply. My point in that is math is a language, isn't it? If you didn't make it in Chinese 1, there's no point in going on to Chinese 2. You can't say, well, I hope it just goes better next semester. No, it's not like history. You did bad in European history, go on to, Asian history. It's all right. They're not completely dependent on one another. But math is a language, isn't it? So my point is, it kills students to socially promote them in math when they don't know what they're supposed to. I mean, I know it's a problem. I don't mean to whitewash it as a simple issue. I know there's all kinds of complex issues. But you'll probably, a lot of you will become into positions of influence in the school system. I really encourage you to think carefully about moving people on in the math world, because what happens is they get moved on to long dividing, and it's true, at any step in math. You get moved on to the next step in math, you really don't know the previous step, you're going to flounder, and it's going to be frustrating. You could be trying really hard in the long dividing section, really trying hard, but you don't know how to multiply. So every time the teacher goes on the side and multiplies, you don't know what they're doing. So you don't know how they're coming up with these numbers. So you don't know how to carry out the rate. You don't know what that is. So you're gone, and pretty soon you're just going to start checking out. Next thing, you're going to be a problem, right? This is what happens. And, I run into people at the junior college. We teach over there arithmetic sometimes. Arithmetic, like adding positive and negative numbers. I actually enjoy those. Those students are really humble. They're really nice. It's actually fun to teach those students. I enjoy them a lot. But what happened along the way? Well, probably a lot of things, really. But there are people, a lot of them have high school degrees. But the truth is, it never happened mathematically. You really have to know the level to move ahead. All right, let's carry this out. So we have to multiply in order to find out how to divide. So 3 times 2 is 6, carry 4, 2 left over. And 3 times 3 is 9, add 1, 10. How many 4s can we carry out of that? 2. That's 2 4s is 8, 2 left over for the 10. 3 times 1 is 3, add 2 is 5. Carry away 4, 1 left over. 1, 1, 2, 2. So will that work? Let's go back and try that. 1, 1, 2, 2. Should we do that one? It's too much, huh? It's too much. I wasn't sure. I really wasn't until we did it. But now I see it's too much. And so what? We're not going to put the 3 up there. We're going to put the 2, aren't we? Because the most number of times it goes in is 2. 2 times the 132 is 3. Kind of scribbling it there. 330. 330 subtract. We good? How we doing? It's making sense? Long dividing is a lot harder than multiplying, isn't it? And that's why you really got to know multiplying. All right, subtract. 2 minus 0 is 2. Now I can't take 3 from nothing. So what am I going to do? I'm going to borrow, huh? Oops, shouldn't erase that 2 there. Going to borrow. This is where we got to be close. See, long dividing is going to involve all the skills, isn't it? Got to borrow. So take from that 1, leave nothing, and bring what? What do I bring to the next column? 4. 4 and 0 minus 3 is 1. Huh? Now I can't take 3 from nothing. Borrow that 1, add 4. 4 and 0, 4 minus 3 is 1. 1, 1, 2. Okay with that subtraction? This is a mess, isn't it? What do we do next? Remember, you bring down, huh? Look over here. Yeah. That's why it is nice to just do those ahead of time. That's actually beneficial. You just have them ready to go. You're like, well, it's 3, right? 3 times 132 is 1, 1, 2, 2, done. So the answer? 23. Base 4. 2, 3, base 4. So that's kind of a mess. We good on that one? Ooh, we have time for one more question so far. So, I'm trying to think, what would be the best way for you to do that? Would you prefer repeated subtraction? I don't care. It doesn't matter to me. Let me go back and redo it again. 11022. Okay. 11022. And divided by 132. Okay. Divided by 132 base 4. This is a redo here. Okay, so the other way, the other method, is just to repeatedly subtract. Yeah. Like, for example, what? Yeah, see that? I don't know. Forget it. I'm not going to try another way. That was just going to use up too much time. And good enough. All right. So let me go. Let me try another one. Okay. Let's try. That's probably the last one we're going to have time for. 1121 divided by 12, base 5. Base 5. It might help if you want. You could go on the side of your paper and just, figure out what 2 times. Yeah, maybe that's a good way to go on these things. I'm going to go over here and go, okay, what's 2 times 12 in base 5? And then what's 3 times 12? And what's 4 times 12? As high as you need to go. And just have those ready. That might be easier for you. So you see all these three answers ready? So I did 2, 3, and 4. That's as high as I can go rather than base 5. I'm never going to see a 5 bigger. So I just did 2, and I know what 1 times it is. No big difficulty there. So I just showed 2, 3, and 4 times my 12. And here's the answers. So I have those ready to go. You know, so when I'm looking at something, I'm wondering how many times it goes in. I have 3 answers ready to go. So give it a try. I'm going to make that long division. We always switch it when we turn it into long division, right? The 12 goes here. I didn't even say anything about that explicitly. Did you notice that? So it's just 2 different ways of writing long division, isn't it? When you do the actual long division symbol, the one that's going in, what do they call that? The divisor, goes on the outside. When you write it with the other kind of division symbol, we write it backwards. I have no idea why. It's just language. There's no good reason for that. All right, so try that out. So first step, can we go into the 11? No, 12 doesn't go into 11. So you got to go to the 112, huh? So now when you're looking at the 112 and you're saying how many times does it go in, start at the biggest. Does it go in 4 times? Yeah, 103. That's smaller than 112. So yeah, so you're going to put it in. And where do you write the 4? Right over the last digit of the number you're going into. I didn't say that explicitly either. So these are all good reminders as you're going to teach kids along the way. Because you're going into the 112, right? So 4 times you put it over the last digit of the number you're going into. So the 4 goes right. And the lineup is really important in long division, isn't it? Where everything is for place values and decimals. When they turn into decimals, we're not going there. We'll do decimals later in the course. But, you know, I think things like spatial, like just kind of lining things up can often be helpful, you know. I think it might be a good idea just to keep things all lined up spatially. So 4 times the 12 is 103. Subtract. Good. All right, what are we going to get there? Let me see. You can't take 3 from 2, so you borrow. And then you add, not 4, 5. We're in base 5, aren't we? Add 5. 5 and 2 is 7 minus 3, 4. How are we going? We're going too fast? So I'm subtracting 103 from 112. Can't take 3 from 2. So I borrow, bringing over 5 in base 5. 5 and 2 is 7 minus 3 is 4. Bring down the 1, huh? Okay, now, it's right here, isn't it? That's why it's nice to have those ahead of time. 3 times the 12 will be 41, done. Where's our answer? Right up here. Right, that's where the answer is to long division. 43 is the answer. How are we doing? Is that making sense? On that? Questions on that one? All right. We will